You're to find the directional derivative of the function f of xy equals 4 minus x squared minus a quarter y squared at the point 1, 2 in the direction of the vector u equals pi over 3i, cos pi over 3i plus sine pi over 3j, leaving your answer to 3 decimal places. Alright. Now, I had worked that out earlier and I got negative 1.866. So I'm going to ask you to work the question out and see if you get that answer too. Alright, so go ahead. Okay, so what did you get? Did you get the negative 1.866? Let's see how this goes. Remember now, to find the directional derivative, you have the directional derivative in the direction of the unit vector of the function equal is going to be the gradient vector of f, right, dot the unit vector. Okay, so it's that product between the grad of f and the unit vector. Remember, to find the unit vector, you're going to have the vector itself divided by its magnitude. Okay, any number divided by its magnitude, the number itself gives you 1. So following that argument, a vector divided by its magnitude give you, well, it's not 1, but the unit vector. 1 is the unit number, but it will give you something here that's the unit vector, right? Now, here you have the grad of f is going to be partial by partial x of f in the I direction plus partial by partial y of f in the j direction plus partial by partial z of f in the k direction. Alright? No. Well, no, you don't have a z here. So this part won't be necessary. We're not going to be using this last part here because there's no z. Alright? Now this is equal to, when you differentiate this partially with respect to x, you get negative 2x. See? And then when you differentiate, this negative 2x is times the I. I don't want to leave that out. Plus when you differentiate this partial with respect to y, you get well, this is going to be negative 2 over 4. In fact, this way I'll just leave this as a minus. 2 over 4 is the same as a half. So a half y in the j direction. Alright? Now at the point 1, 2, the gradient of f, when this is so, x is 1, is negative 2 I, because it's negative 2 by 1 I, minus, at this point y is 2, so it's half by 2. Half by 2 is 1. So it's minus 1j. I don't need to put the 1 there. Okay. That's the gradient vector for the function at 1, 2, or the grad of the function. Now, the unit vector. What is the magnitude of this unit vector? Remember, the vector, or the magnitude of this vector, I should say. The vector is cos pi over 3 I plus j, I put the j first, sine pi over 3. Oh, let's not bother put the j first. Put it after j, following with the same pattern here. Now the magnitude of u will be equal to the square root of cos pi over 3 squared plus sine pi over 3 squared, alright? That's the magnitude. Like you're saying, this is cos pi over 3 plus sine pi over 3, and the magnitude would be this. So this is a right angle, and this would be the magnitude of z, or in this case of u. It's a vector, so it's u. We call it u, which you'll find by Pythagoras theorem. Alright? It's the hypotenuse. Now, one other way to write this is to say cos square pi over 3 plus sine square pi over 3, right? But the thing is, if you use your calculator and do this, what are you going to get? Right? In fact, it doesn't have to be pi over 3. You remember this trig identity. Sine squared theta plus cos squared theta equal 1. Whatever theta is, so that will happen to this. So it's going to be the square root of 1, which is 1. Alright? So fortunately for us, the magnitude is 1, so we're dividing by 1. So we don't have to do as much work as I was considering before. So u, the unit vector, is same as the vector cos pi over 3i plus sine pi over 3j. Alright? Now, what we do is dot both of them. So it's going to be the dot product of negative 2i. Oh, so let me write this part again. Nabla f dot unit vector. So it's Nabla f dot unit vector. So that will be negative 2i minus j, negative 2i minus j dot cos pi over 3i plus sine pi over 3j. Okay, so the dot product of that now will be negative 2 times cos pi over 3 minus, it's going to be a minus, sine, 1 sine pi over 3. Alright. Now, what does this give you? 2 times cos pi over 3. Let's see something here. This is in radians. Oh no. Alright. Where is pi? Pi divided by 3 equal cosine of that. It's 0.5 times 2 is 1. Right? So you're going to get negative 2 times 1 negative 2 times 0.5. When you multiply, you're going to get 1. Let me look again. Right, so when you multiply this, you're going to get 1. Don't know what's going on. What's going on with my thing here? Oh boy. What's going on here? Mixing up the thing, you know. I get lost in all of these apps that are open. Right, 0.5. That's 0.5. Alright. So it's negative 2 by 0.5. Minus. What is the sign of pi over 3 now? Okay. So you have pi divided by 3 equal sine 0.866. It's minus 0.866. Alright? And I should really have it as more than 0.866, you know, because they had said 3 decimal places. So it's good to work it at more decimal places at first. Right? What did I have before? What's going on here? It was pi over 3 equal and sine. Right. 0.86603. Alright. Let's write it as 0.86603. 0.86603. But then what happened? Negative 2 by half is 1, so it's negative 1. So negative 1 minus 0.86603. So what you get is negative 1.8662. That is it to 3 decimal places.